United States. So first thing first, I would like to really thank this organization, Amnisphere, for giving me an opportunity to speak here. Really thankful for that. All right, so let's begin with the presentation. So if you look at healthcare system, so we are really facing a significant challenge in terms of prior authorization requirements, which are creating a major administrative burden and delays in patient care. So this prior authorization is a critical bottleneck that is causing kind of a substantial friction in overall US healthcare system. It is delaying the patient treatment. It's diverting the valuable resources from clinical side, from IT side, and it's actually costing overall healthcare organization billions of dollars every year. So importantly, these delays in terms of care can have very severe impact on some of the patient outcomes, which is definitely a crucial concern overall. And this process of adjudication of prior authorization is extremely complex. I mean, requiring some simultaneous evaluation of clinical appropriateness. Then there are like policy compliance and overall coverage criteria, like the eligibility of your coverage. So this is a multi-dimensional challenge, and it is kind of very overwhelming for traditional processes, which is leading for inconsistent and often arbitrary decision making. So overall, this prior authorization crisis is a major problem that is kind of negatively impacting the healthcare system and most importantly, the patient care. So what we see here is the improvement of this process. I mean, the huge companies, huge IT companies who can invest a lot of resources, money, financially, and even like human resources can advance better in this area because they have all the power to get better in the area. But there are smaller insurance companies who are still struggling, who are still trying to find a ground and see how they can improve. So this data here, it kind of highlights the significant administrative burden and the cost that is currently associated with this one in overall healthcare industry in United States. And we can see that autonomous prior authorization or adjudication system can reduce actually the physician time, the doctor's time by average of 67%. And I mean, this is definitely a very substantial savings in terms of their time. And the annual cost for this administrative cost in overall healthcare system is estimated around 31 billion. This is like a very staggering figure, as you can see. Physicians and their staff, like they overall spend around 14-15 hours per week just related to this activity, which is again a major drain and productivity in their time. So again, like 28% of these authorization delays kind of have abandonment by the patients, which again kind of have this negative impact overall on their health outcomes. And these statistics demonstrate that the urgent need to streamline and to improve this overall process and to reduce any administrative burdens and ensure timely access for any necessary care is required. Again, like the complexity of clinical data, like which includes very unstructured medical records, the data can come from any different sources from the healthcare system. And this requires like sophisticated extraction, which can go beyond simple rule of any system. So coverage criteria, policy language. So these are the language that require some contextual understanding, and it requires a medical judgment to properly interpret the data. And the prior authorization decision, these demand the kind of a simultaneous evaluation of clinical and administrative work. And also there is a regulatory policy and other multidimensional challenge. So overall, the complex edge case scenario required to adopt this reasoning and having that just a monolithic AI system that definitely like has some struggle to provide some consistency, and some traditional automation approach sometimes fall short in terms of handling this overall nuances and then complexity that inherit our healthcare decision making. So now looking at the generative AI model, so what we have shown is like impressive capability, like but but their adjudication reveals the fundamental limitations. And going back to like monolithic architecture, so these are like the large language models that kind of lack specialized expertise that is specifically required for prior authorization. So this is a unique area in the healthcare system. And from clinical data extraction and until the policy compliance verification. And the single mode of this approach kind of really struggles in terms of explainability, requirement, and other critical decisions. So they provide some inconsistent reasoning across similar cases and cannot effectively partition the responsibility for audit and other accountability purposes. And these limitations kind of are definitely necessary more sophisticated architectural models and expertise required for this PA teams. And here, what we are trying to see is show is like multi-agent architecture. So our system kind of takes a distributed intelligence approach, which kind of specialized in agents like AI agents, and which in handling collaborate between each other for handling the prior authorization request. And each agent has a deep domain expertise, which can be a specific aspect of a PA process. And this agent kind of continuously has that communication channel through structured protocol to make some coordinated decisions. A central coordinator kind of ensures that logical flow and consistency of overall decision making. So this system kind of continuously learns and improves and gives feedback and also like analyzes the final outcome much before the final outcome is delivered, like the adjudication or the decision is delivered to the patient or the physician. And here we have this 4 core agent, which kind of specialized critical for prior authorization evaluation. So the clinical data extraction agent. So this is a process which kind of specifically works on some unstructured medical data, lab records, and other clinical notes to identify some of the relevant prior authorization evaluation, handles diverse data format, different medical terminology with definitely like high precision. And then comes the eligibility verification. So validate the patient coverage and the benefits and some of the plan specific requirement, which kind of interfaces directly with our eligibility systems, and it can interpret some of the complex benefit structures across multiple layers. And then we have this medical necessity agent. So this evaluates the clinical appropriateness against some of the evidence-based care and the guidelines, the data that it already has, and some of the best practices it has access to. This also accesses the diagnosis, the treatment alignment, considering the patient specific clinical factors. And then finally, we have the policy compliance agent. So last but not the least, but this is very important because this reviews the authorization against any payer-specific coverage policies, formulas, and other regulatory requirements, ensuring that we are in adherence of both medical and administrative criteria. So these overall, like these specialized agents work together to gather the necessary information, eligibility, medical necessity, and overall the policy, like enabling an end-to-end efficient and compliant authorization system. Yeah, here we have our orchestration and our coordination framework. So this is the core of PA adjudication process, and here the agent acts as if it's a central orchestra, managing interaction between different agents, ensuring our decision making, and it maintains a logical workflow throughout the process, resolves any conflicts between agents, and also like assesses the data, synthesizes the individual contribution. Finally, the coordinator uses some sophisticated routing logic to determine kind of which agent to consult for a specific case type and manages the parallel processing for efficiency. And also, it kind of ensures all required evaluation and all the dimensions are addressed appropriately. So this kind of approach, like overall, it will balance throughout the processing with the speed while maintaining some of the audit trials and also like agent interactions overall for a decision process. In the communication protocol here, what we have been using is like architecture that kind of enables structured data exchange between the agents and their, and we are kind of continuously using this JSON schemas. This kind of ensures some consistent information, which is always required for our system. And it provides a real-time monitoring of the agents as well, like the progress and intermediate decisions that continuously that we take for tracking the status. And each agent again kind of it documents their decision based on the logic and also the evidence, like promoting the reasoning, the transparency, and enabling the auditing. Overall, this integrates the agent outputs into kind of a very robust system, which is kind of finally useful for providing a final synthesis data. And here, what we are seeing here is some of the comparison between multi-agent AI systems and single model AI approach. So this is the overall industry right now. Like I think you all know, everybody is talking about AI agents. Here, like we are trying to see if we can compare the multi-agent versus the single monolithic AI. So the key performance metrics that we are showing here is like the decision accuracy, explainability score, and some of the consistency rate, and again like audit and edge case handling. So the multi-agent system kind of always demonstrates significantly higher scores across like all these critical dimensions compared. And like definitely having more agents are always better than having just one, right? So this distributed expertise model with the multi-agent system enables like more accurate decision, better explainability for stakeholders, higher consistency, and definitely it's going to be a very trustworthy system for healthcare automation. And these results here overall highlight the advantage of multi-agent kind of architecture over like the generative AI approach. I'd like to just pause here and see if you have any kind of questions or anything that you didn't understand. There are some terminology that are like specific to US healthcare system. So really want to pause here and see if you have any questions. All right, let's see, we can move on. So then again, like coming to the key focus here, right? So what is the key focus? So what we have is like how our multi-agent system kind of achieves superior accuracy and consistency in overall like adjudication or determination of prior authorization for a medical need. And this agent, like each of which is optimized for a particular task, they work together. They reduce propagation and enable the targeted performance improvements without like disrupting much the entire system. And this specialized approach like usually leads to a measurably uh, high accuracy compared to general model. And like overall, it handles the model, the system kind of in an accurate and consistent way throughout the process. And then finally, the visual, like here, what we are seeing here is like through standardized agent reasoning framework and the structured communication protocols, ensuring that we are able to reproduce the decision-making needs over and over again. And here the key aspect, again, like for explainability, right? So, and for even for auditing our system. So these agents are really helpful in terms of reasoning, having a decision trail, evidence mapping, stakeholder transparency, and overall the quality assurance. Excuse me. So each agent here, it is specific to evaluation logic. The evidence is kind of continuously reviewed and intermediate conclusion as it reaches. So this kind of provides overall transparency into the system, and we maintain a complete audit log of inter-agent communication, information flow, and throughout the adjudication process. And this decision trail kind of allows us to comprehensively have a auditing mechanism and structure. And overall, this like directly links to the clinical data. and the policy criteria and the final determination component, and overall it kind of enables a clear evidence mapping. So there are like four levels here overall for the escalation framework. So as you can see here, the level one is full automation. So routine cases that meets full confidence thresholds are kind of automatically processed with some of the complete documentation. Level two is usually kind of flagged. So cases with some moderate complexity, which kind of receive automation, but still there will be a little bit of human interaction or interference required for verification purpose. And then level three is again like detailed analysis. So these are kind of a really complex cases which need some comprehensive agent analysis. Plus some clinical expertise are required. Probably a doctor or MD needs some intervene and make that decision or determination. Then we have level four, which is again like a committee review. And these are done for some of the exceptional cases which require some multidisciplinary evaluation with having like full support from the clinical teams, from the compliance team, from the committee teams, and overall require some additional documentation. So here we see the real world performance, like the outcome which after the implementation of our solution in my organization. So we see like 67% reduction in the processing time for overall prior authorization compared to the final determination. The first pass of approval rate is like more than 89%, meaning that most of the appropriate requests are approved without any additional review or without any human interaction. So there is again like 92% of clinical agreement rate between like our system's determination and physician or doctor's review assessments. And overall, we have achieved around 78% reduction in the administrative burden of like between the prior authorization processing time compared to now and before. So these kind of some of the key metrics which kind of definitely demonstrate some substantial operations improvement while maintaining some of the high accuracy, high standards that we deliver across clinical systems. All right, so moving on. So the key regulatory and compliance advantage, what we see here is our solution kind of includes some of the standardized documentation, audit trail, policy version controls, and overall it kind of mitigates the bias between the between each protocols between the agents. So every authorization here maintains a complete, consistent documentation that meets our regulatory requirement. And this system kind of tracks overall the policy versions informed between each decision, enabling some of the retrospective analysis to go back and see. And also kind of it does have a appeal support. Appeal and grievances is another part of healthcare where a patient can appeal their outcomes from the clinical decision. So unlike kind of a black box AI system, our system kind of this particular approach provides some transparency and accountability, which are kind of definitely essential for overall healthcare administrative workflows. And again, they are subject to some of the regulatory oversights. So the scalability, right? So this architecture is designed to handle enterprise scale. Like we have implemented this for over 15 clients now, and we have still more to come, and integration is on the way. So this system kind of connects through EHR records, the payer adjudication, eligibility verification, and overall the standardized APIs in terms of data exchange protocols. And this is a phased approach, which kind of reduces the implementation risk and allows the validation of the system performance before the volume fluctuation with agent, and kind of overall, if you look at the cloud native deployment here, this ensures the availability and overall disaster recovery and overall maintaining the strict data security and also the privacy. So the successful deployment of the system, which kind of requires a clean, structured clinical data and comprehensively the policy documentation, we must kind of assess that the current data quality and implementation, necessary standardization kind of before even kind of deploying into the system, before making it live or before productionizing the system. The clinical and overall administrative, like the staff, what we need for training the system, escalation protocols, appropriate mechanisms. They kind of continuously engage the stakeholders throughout the implementation process to help ensure there is a smooth adoption of our new agents. And then we have this continuous monitoring, like dashboard reports, to monitor the decision accuracy, processing efficiency, and finally the clinical outcomes, and which is very, very crucial to validate system performance. And regular audits are definitely necessary and incorporate some of the feedback, like the feedback loop, that will kind of drive some of the ongoing improvement to our overall model. So what do we see like in the future? So future is definitely bright, at least for the healthcare side of things. Here, like we are moving towards a greater autonomous intelligence. So our research kind of we continuously expand in capabilities of using this multi-agent architecture, not just in handling prior authorization, but this should be able to handle more complex healthcare overflow workflows, which kind of claims like processing, utilization mechanism, care coordination, and we are kind of continuously developing advanced agents for appealing this process that can leverage some of the historical data. So data is God right now. So kind of it depends on the historical data, decision patterns to make some more critical assessments, and also like improving this natural language processing area will allow the system to kind of better interpret some of the complex documentation, and kind of the policy is always ambiguous, right? So this can improve better policy making as well. It's a collective effort, to make this learning and make this advancement in the process to overall improve the autonomous healthcare administrative system. So finally, like just to summarize, like the key focus, what we discussed is like how our prior authorization system, which kind of uses a distributed multi-agent AI architecture to actually transform and improve the prior authorization process. The traditional approach to healthcare AI is being replaced by all these autonomous process right now, and they are kind of better than mimicking some of the human decision making. And this system leverages some of the specialized AI advantage agents, and it is an advantage to have to manage some of the complex workflows, ensuring transparencies, accuracy, and overall accountability for the entire end-to-end system. The future of healthcare systems, like they rely on the augmenting the human expertise through the AI agents again. And it can be more transparent, more collaborative systems, which kind of enhances both efficiency and quality of care. Yeah. So finally, thank you. Thank you for staying here. So let me know if you have any questions, anything that I can help you answer.
Thank you, Mr. Rakesh. If anyone has any question, they can raise their hand.
Yeah. Thank you, Mr. Rakesh, for this wonderful topic as well as insightful presentation. I have one question, and my question is, how do multiple agents coordinate and resolve a conflict when making authorization decisions in real time?
So yeah, as I was explaining, right? So each agent is kind of focused on particular area. The scope of the each agent, like let's say that the first agent will just look for the clinical trials or clinical decisions, and the second agent will look for the eligibility, the member eligibility, the plan-based criteria. So there is definitely a boundary set between the agents, and there is very little overlap that kind of has this conflict between each agents, and it's kind of we have to it's a very fine line, right? So where do you stop? How much do you kind of have this overlap capability? So you will have to design, you'll have to plan accordingly to have a minimum overlap, and there is less conflict between the agent themselves. So all that systems are in place. So we are working towards that, and the results have also proved for us that we have shown some consistent improvement in terms of productivity, efficiency, and overall performance improvement.
Thank you, sir. I got my answer.
Thank you.
Thank you, Mr. Rakesh. Now, next, we move on to our next keynote speaker, Ms. Yasha Patel. Ms. Yasha Patel is a technical architect specializing in AI-driven enterprise system with expertise in cybersecurity and zero trust architecture. Her topic is cyber resilient AI, protecting AI pipelines, models, and data. With that, let us welcome Ms. Yasha Patel.